So to start discussing about ellipse, we are firstly considering ellipse as conic section whose eccentricity is less than 1. And for our benefit, if we try to consider standard ellipse, motive exactly the same that we have considered for parabola, that to know the attributes of ellipse, we need it into our comfort domain, that is around origin. So we will standardize an ellipse on the basis of if we can get it centered at origin and axis along x-axis. Firstly, we are standardizing in that way. So if we are trying to have our axis of ellipse along x-axis, say this is x-axis. So we have marked the focus S on x-axis and directrix ZM as a perpendicular line to x-axis. Now the points of the ellipse which are on the axis, that is the vertices will satisfy their distance ratio from S and Z as E is to 1. So accordingly, we will get some point we will get some point A and some A dash, maintaining that SA by AZ is same as SA dash by A dash Z is E is to 1. We know that E is supposed to be less than 1 for ellipse. That is why the section point, the internal section point as well as the external section point, they will be respectively closer to S and ZS extension. Okay?
Yes, sir.
The internal section point will be closer to S, as I have drawn. It's closer to S. And the external section point will be on ZS extension, so that it is also closer to S. Okay? Now, A and A dash, this distance we have marked as 2A, and the point of symmetry of the ellipse must be the midpoint of A dash. So we should get it at this position. So it's been marked as the origin. Our target is to have center at origin. So A dash 2A, and ahead of that we have gone for midpoint of A dash, which is supposed to be the center, is origin. Okay, that means we can confirm out of this discussion that OA is same as OA dash, and both are small a units, right?
Yes,
sir.
So in particular, I can mark coordinate of A as small a comma 0 and A dash as minus a comma 0.
Yes, sir.
Right? Now, SA is E times AZ, right? And SA dash, that's E times A dash Z. If we go
Yes.
for 1 added to 2, so if we add this to relation, what will we get? SA and SA dash. If I add this to, what will
2A
we
is
get?
equal 2A is equal to E into AZ plus A dash Z.
Very good. 2A is equals to E into AZ plus A dash Z. Now, as we are targeting the coordinates of S and Z, so we will try to split AZ and A dash Z in terms of measurement from origin. So 2A by E, that is AZ, you can identify AZ is OZ minus OA, right?
yes, sir.
Yes, sir.
Yes, sir.
It's OZ minus OA. added with A dash Z, you can identify it's OA dash plus OZ.
Yes, sir.
So for marking purpose, it's AZ, which has been represented as OZ minus OA. And we can think of A dash Z, that's been marked as OA dash plus OZ. Okay. So if we perform the addition of these two, that gives us twice of A
Twice,
by E
twice OZ.
is equals to twice of OZ. OA and O dash been equal. Once appearing in positive and negative, they will be cancelled out. So that confirms OZ is A by E. And as soon as we get that, we can mark this line X is equals to A by E, the coordinate of Z as A by E comma 0.
Yes, sir.
Is it okay for all?
Yes, sir.
Moreover, if I go for 2 minus 1, in that case, we will get SA dash minus SA is equals to E times A dash Z minus AZ. Now look into this diagram. From A dash Z, if I subtract AZ, what should we get?
A dash.
A dash, that length is known to us.
Yes, sir.
Whereas as per our target, we can look for SA dash in terms of origin, distances
A
from
dash O
origin.
plus OZ plus S.
So that can be marked as A dash O plus OS, whereas SA is OA minus OS is equals to E times 2A. Again here, this SA is been found as OA minus OS from the diagram, and SA dash been found as A dash O plus OS. Okay, can you all follow this from the diagram?
Yes, sir.
Okay, once this is done, now we can get its left hand side is twice of OS, or simply we can directly write OS is AE, cancelling out the twos.
Yes, sir.
As soon as we have got that,
We get the focus.
have got to AE comma 0, right?
Yes, sir.
So now we have got the focus S, we have got the directrix ZM, so we can target the ellipse. Must satisfy that distance from S, that's x minus AE whole square plus y square, or better to write square of the distance from S is same as E square times its distance from the directrix. Right? Is it okay with everyone?
Yes, sir.
Yes, Yes. sir.
Now, if we open the squares, what we have got is x square minus 2aex plus a square e square plus y square is equals to e square x square minus 2aex plus a square. So any term which is getting cancelled from either side,
2ax.
this can be cancelled from either side.
Yes,
Okay.
sir.
And to keep the leading coefficient, that is coefficient of x square common, we can identify e square is less than 1. So we have shifted these terms to the left hand side just to keep coefficient of x square positive. So taking the terms to left hand side, we have got 1 minus e square into x square plus y square is equals to constant term on the other side, a square into 1 minus e square. And e is a positive number between 0 and 1. So
Yes.
1 minus e square is a similar positive number between 0 and 1. So if we divide the whole equation with the right hand side, we are going to get x square by a square plus y square by a square into 1 minus e square is equals to 1. That is x square by a square plus y square by b square is equals to 1, where b square been considered as a square into 1 minus e square. Okay. So this is a relation which is very, very important. We need to keep this in mind because we can think of this relation in other variations also, means the same relation, but how we are going to write it, it has many variations. Like let us have a look in some of the variation. We can write the initial assumption b square is equals to a square minus a square e square. So we can definitely have one of the possible representation also. E square is equals to 1 minus b square by a square, right?
Yes, sir.
So once we know this A and B measurement, this can be a way of representing eccentricity also. We
Yes,
can
sir.
also think of another outcome, that A square minus B square, that's A square E square.
Yes, sir.
Okay, so that is also a possible way. Okay, so we can have different times when we will be using it in some different form. So all these formats that should be very crystal clear to us and should be in our tips in terms of using these results. Okay, basically it's the same thing, but when to change and what to change, we should be comfortable in all these three variation, or better to say in all these three factorial variation. There were three terms being related, b square, a square and a square e square. So whatever three factorial variation you can think of, you can consider that as a feasible way of representing and might be useful while simplifying other results. So far is it clear? Now what we have got as the equation of the ellipse, this is our final ellipse. Now if we try to consider this one, this is going to have its appearance symmetric about x-axis. And how we can conclude so? Because replacement of y with minus of y does not make any change. So what we are going to get is symmetric about x-axis. Is that okay with everyone?
Yes.
Moreover, if I replace x with minus x, still no change happens. So what we are going to draw, that must be symmetric about y-axis also,
Yes, sir.
right? Moreover, from this relation, we can also write x square is equals to a square by b square into b square minus y square, right? And that confirms that this relation holds good, or better to say mod x is equals to a square, or as we have considered a and b as length, so I am writing only a and b, not mod, a by b into square root of b square minus y square. These are the conclusion we can take out of this equation, right? Is it okay with everyone?
Yes, sir.
So as soon as we have got that, we can identify that this relation is true only if mod y less than equals to b.
Yes.
So this exists for mod y less than equals to b, right? Because if mod y is more than b, then b square minus y square is negative, and hence under square root, if we get negative value, that's non-real anymore. Is it okay with everyone?
Yes.
Yes, sir.
Now, within the variation of mod y from 0 to b, we can identify as mod y increases, y square increases. If y square increases, then b square minus y square decreases.
Yes, sir.
That means mod x decreases.
Yes, sir.
So as mod y increases, mod x decreases. So
Yes.
when mod y is minimum, that is
Mod x.
y is equals to 0, then mod x is maximum.
Yes,
So
sir.
that means the curve we are about to draw, that must have its maximum horizontal span a dash, which is on y is equals to 0, right?
Yes, sir.
Yes, sir.
So this conclusion can be taken. Okay.
Yes, sir.
And the minimum value of x will be found when mod y is maximum. So at mod y equals to b, we will have x is equals to 0.
Yes, sir.
So that means the curve is going to meet the curve at 0 comma plus minus b. So let's mark these points. This is y-axis.
স্যার লাস্টে আপনি কি বললেন একবার বলবেন, ঠিক করে শুনতে পাইনি।
If mod y is maximum, then mod x is minimum.
Yes, sir.
Now mod y can be at
Yes,
most
sir.
b, then
B,
mod x is
yes.
0.
Yes.
That means the curve we are about to draw must meet y-axis at 0 comma plus or minus b.
Yes, sir. Yes, sir.
Is that okay with everyone?
Yes, sir.
Yes, sir.
Just a moment. Okay, so this is y-axis, and there will be some points 0 comma b and 0 comma minus b through which it passes. Okay, as an alternate formation, we can also represent this thing as mod y is equals to b by a into root over a square minus x square. So even from here, we can take this similar conclusion that this exists for mod x less than equals to a. And even now also, as mod x increases, x square increases, and hence a square minus x square decreases. So mod y decreases. So we have identified that mod x and mod y should vary oppositely, or should vary inversely on the curve. If one of them increases, the other one decreases.
Yes, sir.
Mod y must vary between 0 to b. Mod x should vary between 0 to a. That means, accordingly, we can think of a rectangle to contain this whole curve, and the rectangle which is going to contain our curve is going to be of this variation. Just a moment.
The vertices of the rectangle should be a comma b, a comma minus b, minus a comma b, and minus a comma minus b.
The vertices are only two, a comma 0 and minus a comma 0.
No, the rectangle.
Yeah, the rectangle will have this vertices. Okay, so we just need to extend it a bit more. Okay, so this rectangle, which is been formed by y is equals to b, y is equals to minus b, x is equals to a, and x is equals to minus a. This rectangle must contain the whole curve inside, right?
Yes, sir.
And as mod x increases, mod y decreases. Now this is a second degree curve. So at this moment, we will just simply draw and you should follow it. Afterward, using monotonic behavior and convexity, we can get to why it should appear like that. Like in the first quadrant, if I draw the part of the curve, it will be sufficient to complete the whole curve by the symmetry about x-axis and y-axis. And what we can
Yes.
find that the curve must appear like this in the first quadrant, and hence overall symmetric curve should be like this. Okay, so this should be the final curve. Is it okay for all?
Yes, sir.
Yes,
Yes,
sir.
sir.
By the initial idea, we should draw only this much, and other parts can be completed by the idea of symmetry. So we have got our ellipse with already two vertices, a and a dash. That's a comma 0 and minus a comma 0. The axis along x-axis, okay, and the length of the axis is 2a. The directrix along x equals to a by e, right? But we can identify that other than the axis, there is also another line of symmetry for this curve. Though this is not the perpendicular line of directrix through axis, through focus, but still it is doing the job of an axis.
Yes,
It's
sir.
generating symmetry for the curve.
It has two
That is
axes,
why-
sir.
No, axis is still one, but this is just another line doing the job of an axis. Okay, axis is unique for every conic, and it is the
Yes, sir.
line which is perpendicular to directrix and passes through focus. Definitely, this line is not satisfying that, but this is just another line generating symmetry for the curve. So, doing the work of an axis, and hence we acknowledge it by giving it a name similar to axis, and we mark it as minor axis. And to identify the actual axis, we name it as measured axis. So that means the ellipse we have constructed so far has its actual or original or measured axis along x-axis, while the minor axis is along y-axis. The extremities of measured axis are the vertices A and A dash already found with coordinate, and the extremities of minor axis we can mark. We have decided that through the variation of mod x and mod y. So the upper extreme point B must have coordinate 0 comma small b, and B dash must have coordinate 0 comma minus b.
Yes, sir.
Is it okay with all?
Yes, sir.
Yes, sir.
Yes, sir.
Now this curve is symmetric about both these lines,
Yes, sir.
right?
Yes.
So if I reflect the curve with all its references about x-axis, will anything change?
No, sir.
So that's the benefit of actual axis. But if I reflect this ellipse with all its references about the other line of symmetry, then will there be any change in the ellipse?
We will get another focus and a directrix.
Very good.
Yes,
So
sir.
no change in the ellipse, but we are going to get another point S dash as image of S, and we are going to have even another line as image of Zm, say some Z dash M dash. Okay. So we can consider this ellipse also with the pair of focus and directrix at S dash and along Z dash M dash. Is it okay?
Yes, sir.
Yes, sir.
Like if we reflect the whole diagram with respect to its line of other line of symmetry y-axis, we can identify the image ellipse will remain the same, but we can found a new set of focus and directrix with the new focus at S dash and new directrix along Z dash M dash, and still the ellipse be same. So we can think of the ellipse with two set of corresponding focus and directrix. We cannot say two foci S and S dash and two directrices along Z M and Z dash M dash, because if you consider the focus S and the directrix Z dash M dash, it should have been some other ellipse.
Yes, sir.
So we have got two set of focus and directrix. One set is focus S and directrix Zm. The other set is focus S dash and directrix Z dash M dash. Okay. And
Yes.
we can identify their coordinates also
Yes, sir.
as their reflection about y-axis. So definitely S dash is minus AE comma 0. And Z dash M dash is x is equals to minus A by E, right?
Yes, sir.
So distance between the two foci,
2A.
2AE. That is E times the length of measured axis, and distances between the directrices,
2A by E.
2A by E.
2A by E. Can we try to construct the lattice vector? There will be two, right?
Yes, sir.
Yes, sir.
If I consider the first lattice vector, that's through S, it will be something like this. Okay.
Yes, sir.
Can we get to its extremities? Say we have marked this as L1, L2. So can we identify L1 and L2? Equation of the lattice vector? First of all,
X equal to A.
X equal to A.
x is equals to A. So L1 and L2 are common point of x is equals to A and the ellipse.
Yes, sir. We can substitute
sir.
the value.
So just substitute. So what we have done for L1 and L2, we have gone for x is equals to AE. Okay. So on association with x squared by a squared plus y squared by b squared is equals to 1, we must have a squared e squared by a squared plus y squared by b squared is equals to 1, right? So that means y squared by b squared is equals to 1 minus e squared. And if you can identify this 1 minus e squared is this section, which can be written as b squared by a squared. Okay. So let's make it another formation. Right? Is it okay?
Yes, sir.
So if we use this fact over here, so we can also replace it with b squared by a square. That means y squared is appearing as b to the power 4 by a square. That is y is equals to b squared by a or minus b squared by a. So accordingly, we can mark L1 as AE comma b squared by a and L2 as AE comma minus b squared by a. Is that part okay with everyone?
Yes, sir.
Yes.
Let's have a look on the diagram. So this point is AE comma b squared by a and this is AE comma minus b squared by a. So can we mark the length of the lattice rectangle?
Yes, sir. 2b squared.
So that's 2b squared by a. Clear to all? Similarly, if we have another lattice rectum through S dash, can we have its length differing from the first one or should it be of equal length?
Same length.
Equal length.
Equal length.
Okay. So if I draw another one from here, so marking the extremities as L3 and L4, we can have the other lattice rectum with equation x is equals to minus a having same length, and accordingly L3 can be marked as coordinate minus a comma b squared by a and L4 with the coordinate minus a minus b squared by a.
Yes, sir.
So far, is that clear?